Okay, so on Friday, tomorrow, is your beginning of chapter 11 test. It's going to cover lessons 11.1, 11.2, and 11.3. From 11.1, you need to know the circumference formula. So the formula to find the circumference is either pi times diameter or 2 times pi times radius, or just double the radius and then put pi. All of the answers, except for later on, maybe when we're doing the area of a polygon, all of the questions, or the majority of them, are all left in terms of pi. You will not be using a calculator. You will not have to use 3.14 for pi. So for example, questions 1, 2, and 3 here on this first page, these would be excellent examples of what you could do for tomorrow's test. So for example, let me make a new one so you guys could actually go back and do these. So let's say I gave you a circle. You may not get a picture, it just may be in words. But let's say I told you you have a circle and it has a diameter of 10. What would be the circumference of this in terms of pi? You would just do 10 pi. Okay, now if it's got units on the question, you would just put 10 pi inches. Now, if there aren't units in the question, you would just put 10 pi units. So if I don't have inches or centimeters or some kind of unit labeled, just label it as units. Now, if I gave you a circle with a radius, and let's say I told you this radius was 7. What would be the circumference in terms of pi? 14 pi. It's 2, you do 2 times the radius and then the pi symbol. And again, if it didn't have a unit labeled, you would just put 14 pi units. It's going to be that easy on the test tomorrow. Okay, now if I already give you the circumference calculated, like on number 2, and I say find the radius, so for that type of question, let's say they gave you a circle and they said circumference equals 57, and they say find the radius. For this one, what we're going to do is we'll take the formula, because they're asking us to find the radius. I'm going to set it up as 2 times pi times radius equals circumference, or you could do C equals, it doesn't really matter, but I'm going to go ahead and put 2 pi r equals 57, and now I have to solve my equation for the letter r. And to do that, I'm just going to divide both sides by 2 pi. Now, if 57 could have been divided by 2, you would have done that. But because you can't, just leave it in proper. 57 over 2 pi. The location of pi is important. If you put it up in the top, it's wrong. Okay? Because you're dividing by 2 pi. Okay? I'm not going to make you divide that and give me whatever 57 divided by 2 is. Now, if I gave you something that was divisible by 2, let's say I told you the circumference was 24. For this one, you would do 2 pi r equals 24, divide by 2 pi. 24 you can divide by 2, so you would tell me the radius is going to be 12 over pi. Okay, so if it's possible to simplify, definitely do that, but don't leave me any decimals in the fraction. Okay, so this was it for circumference. You're leaving it in terms of pi. Okay, and if it has units, you include the units. The units are just whatever they are. Any questions on the first page of the study guide here? So 1, 2, and 3 are excellent examples you can do. Okay, then the next ones, 4, 5, and 6. Those are also excellent examples. You will have to find the length of an arc. Okay, the questions down here for example 3, you will not have to do. I'm not going to already give you the arc length calculated and I'm not going to expect you to work backwards, but you will have to find an arc length. So for example, I'll just walk you through the example and I'll leave 4, 5, and 6 for you to do on your own. So if I did the circle that's given there, and it has a 150-degree central angle with a radius of 5, the formula we're using here is the length of the arc is equal to the measure of the arc, which is in degrees, over 360, times the circumference formula. So in this case, they gave me a radius, so I'm going to use 2 pi r. Okay? In this type of question, you're just simplifying the fraction and leaving it in terms of pi. So put it in simplest form. So for this one, I would have put 150 over 360, and then 2 times pi times the radius, which was 5. I could cross off my zeros first. You can simplify your fraction, whatever you're comfortable doing. The next thing I can do here is I could divide them both by 3 and make this 5 over 12. And then I still have the 2 and the pi and the 5 here. If you want, you could multiply the 2 and the 5. I'm going to simplify that.
Minus interruption. Those attending today's track meeting.
All right. So here I simplified the 12 and the 2, and I made it the 2 a 1 and the 12 a 6. So now I'm going to multiply what's left. I can't simplify anything else. So I'm going to multiply straight across. 5 times 5 is 25 pi over 6. So left in terms of pi, that is your answer. We are not going to multiply it out. We're leaving it in terms of pi. Pretty good on that? All right, so you will have those. So that is the formula you need to memorize. So from lesson 11.1, you need to know the circumference formula, either 2 pi r or pi d, and then also this one right here, that the length of the arc, the pizza crust, is equal to the measure of the arc divided by 360 times the circumference formula. If you're given a diameter, you could just put pi d here. So in the notes, you were given a question, and let's say your car has a tire and its diameter is 27 inches. I want you to find out how far the car could go if the tire makes 50 revolutions. So in the notes, it was different. It asked you how many revolutions it took. So this one's a little different. I want to know how far does this car move when the tire that has a diameter of 27 inches turns around 50 times. So in order to solve something like this, we need to find the circumference of that tire. So what is the formula for circumference when I know a diameter? Pi d, right? So I'm just going to do 27 pi, and because I want to know how far it travels, I'm going to multiply that by 50. So we're going to actually do 50 times 27, and then just put the pi symbol behind it. So 1,350 pi inches. That's how far that tire rolled when it turned 50 times. So that would be your word problem that you're going to encounter from lesson 1. The next lesson was 11.2. That was where we encountered the area formula. So the formula for area of a circle is going to be pi r squared. Remember, once we calculate our answer, the units are always squared. So if you look at examples or example 1 and then the exercises for it, those would be all good examples that you could do to study for the test. But if I gave you a circle and I gave you a radius, and we're leaving this in terms of pi, if I gave you a radius of 4, what would be the area? Good. 16 pi, and because I didn't give you units, it'll be units squared. So all you have to do is square the radius. All right?
What were the good examples? Sorry.
1, 2, and 3. Okay? Now, if I also, what if I gave you a diameter? What if I told you the diameter was 10? And I said, find the area of this circle and leave it in terms of pi. What would we have to do first? Good. We need to turn this into a radius first. So divide it by 2, make it 5. Okay? Now what's the area? 25 pi. And again, it's units squared. Okay? So this is the type of questions you're going to see. Okay? All you're doing is basically manipulating either the radius or the diameter first, and then just putting the pi symbol. Okay? Nothing as complicated as we saw in the homeworks. So this is a good explanation here for the vocabulary. Now, when we did this formula, this was the area of the entire circle. In this lesson, we also learned how to find the area of a sector. And this is where we talked about the sector as being like a piece of pizza. So on the second slide of this study guide, they've created sectors. Now, when we did the homework, it said find the areas of the sectors. And I know some people only did the gray area, but really what they were looking for was to find the gray and the white. On the test tomorrow, it's only going to say find the area of the shaded portion. So you're not going to find more than one sector. Okay? You're not going to have to get an answer and then have to use it again. Each question will have its own answer, and then you're done with that question. It's not going to be like the homework where you had to get the answer to 14, to answer 15, to answer 16. Each question will be separate. Okay, so for this one, it looks like the same formula we saw in 11.1, where we did the length of the sector. Now it's going to be the area of the sector is equal to, again, the measure of the arc. So this part is the same, over 360. But what's different is what we multiply it by. So in lesson 1, we use the circumference formula. When we're doing area of a sector, we're using the area formula. So then now what you'll do is you're going to look at your picture and you're going to find the measure of the central angle, which is also going to be the same as the arc measure. Put it over 360, put in your radius and square it, and then start simplifying. So again, we're not going to be working backwards. All we're going to do is find the area of the sector. You will be given the arc measure or a central angle measure, one or the other, and then the radius. Just remember the central angle and the measure of the arc are the same. So for example, if I just redo the one that they've done there, the one that has, it's got a measure of the arc is 160 and the radius was 10. And then 360. And then now all I'm going to do from this point forward is simplify everything. Now, if it's easier for you not to multiply that 10 squared and simplify first, you can do that. So I'm going to first cross off my zeros, and then I'm going to make it 16 over 36. Now I can either square the 10 and make it 100, or I can even leave it apart as 10 times 10. And then I can now start simplifying. So my 16 over 36, I can actually divide them both by 4, and I can make this 4/9. Actually, there's nothing else I can simplify with my 10 and 10, so I can multiply that back and make it 100 pi. And then I still have to multiply it with the 4/9. So 400 pi over 9. Again, you're leaving it in terms of pi. You're not having to multiply anything. So that would be the area of that sector. The units on this was actually inches, and because it's area, the units are always squared. So whatever unit is on your picture or given in the problem, it's going to be for area, it's always units squared. Pretty good so far? So in these examples, again, I'm not going to ask you to work backwards, so really number 5 wouldn't be a good example, but number 4 would be. Okay, so when we did the notes on this lesson, I'm going to add a slide here. There was a question in the notes, and I think we also did it in the homework, where they gave you a sector, then they gave you a segment, and then they said, find the area of the shaded. So find the area of the green. So when you're encountering, and we're going to cover this, I'll do another one with some numbers. This is the one where you're going to find the area of the sector, like I just did, and then subtract the area of the triangle. And we're going to leave this in terms of pi. Okay, so I'll do an example of this. I'll see if I can find one maybe from the homework, and I'll work this out. We did it in the notes, so I can also go back and do that one. Let me just go on to 11.3 and cover that before we run out of time here. All right, from 11.3, this is where we learned how to find the area of a polygon. Okay, we knew basic formulas like area of a triangle, area of a rectangle, square, but we never had to calculate, say, the area of a hexagon or an octagon or a decagon. So this is the formula that we're going to use. So the formula to find the area of a polygon is going to be, and we saw this yesterday, 1/2 the apothem times the number of sides times the side length. My recommendations to you, and we saw this in the notes yesterday, is first check to see, do you have the value of the apothem? Do you know how many sides you have in your figure? And do you know the side length measurement? If you already have all 3 of those, then just plug them right into the formula. Don't try to turn it into a special right triangle. And what I mean by that, let's say I told you the question stated, find the area of a decagon with, actually, and remember, this is only for regular figures, with a side equal to 5 and with an apothem equal to 3. So from here, we can fill in what we know. How many sides are in a decagon?
10.
Okay, and we know our apothem was 3, and we knew our side length was 5. So if in the problem they're already giving you the 3 pieces of information, don't worry about trying to draw a decagon and making it a triangle. All we're going to do is 1/2 times 3 times the number of sides, which is 10, times the side length. So I can simplify if I want. I could divide 10 by 2 and make it 5. And then 3 times 5 times 5 is 75 units squared. So and that would be the area of that decagon. So it's that basic, if they give you all 3 things. However, on the test tomorrow, you will also have a question where the figure is either going to be a square, a equilateral triangle, or a hexagon. All three of those figures, when they are inscribed in a circle or a circle circumscribed, you do not need trig. So you will turn them into special right triangles to find either the missing side or the apothem. Okay, so you will have to actually do some trig on that. So let's look at the examples here and see which one would benefit us. So for this one, notice this is a hexagon. We can do a hexagon without using trig. So this is a good example if it said to find the area of this. However, the nonagon here, this one would involve trig. So this wouldn't be a good example to try to find the area of. You could practice finding the angle measures, that would work. Now, you also need to know how to find a central angle. How would I find the measure of this nonagon's central angle? Anybody know the formula to find the central angle? Jason? Good. Okay, so to find the measure up here of this J, or EJD, is I'm going to do 360 divided by 9, and I get 40 degrees. So that is actually the measure of DJE, which is the first answer. Now, this is going to sort of help you see how you're going to solve the hexagon and the equilateral. Once you find the measure of the central angle, then what you're going to do is you're going to drop down the apothem. And then that's going to create a right triangle. We just found that this angle up here at the top is 40. The apothem splits it in half. So the measure up here at the top is 20. Over here is a right angle, and then down here would be 70. Now, if this were a question and we didn't cover it yesterday, if you needed to actually find the length of this apothem, this is where we would do the trig. But on the test tomorrow, once I pull this triangle out, it's either going to turn into a 30, 60, 90 or a 45, 45, 90. And you guys know the rules for that. And that's what you're going to use. I'm going to see if I can find an example so I can show you this. So this one is just good to show you how they found the angle measures. So notice DJK is this angle up here, and we found it to be 20. And then JKD is the right angle. And that's what I just pulled from here. So know how to find the measure of a central angle. Know how to find the area of a polygon when you're given all three things already. Know how to find the area when it's a hexagon, an equilateral, or a square inscribed in a circle. So let's see what we have here. I don't believe you will have some shaded stuff where you may have to find some stuff, and you would find one area and subtract the other. So you will have a question like that, but again, you're leaving it in terms of pi. So what I'm going to do now is I'm going to go back to the notes, and I'm going to show you again the questions where we're going to find the area of an equilateral triangle, and we're also going to find the area of the piece of the sector. So this question here from 11-2, where I'm finding this area, and then I'm also going to go redo from the notes the question where it was an equilateral triangle and find the area of that. So I'm going to go back to those questions from the notes. The test tomorrow has 15 questions. Again, the majority of them are left in terms of pi. Okay, the other simple ones, like when you're finding the central angle, yes, you're dividing, but it's easy numbers. Okay, so you are going to have to do some division, but the numbers are manageable. So just make sure you've memorized all the formulas you need and know how to use them. Pretty good on that? All right, so I'm going to go back to the notes, but that is what is on your test. So again, make sure you come tomorrow with a pencil and a good eraser, but no calculator. because it's all in terms of pi.